This is section 11.5, the first day, and we're going to do areas of sectors. So we have done arc length, which was like this path out here. How far was this if I had to walk it? And now we're going to talk about the area, so that whole shaded kind of pie piece there in our circle. And the formula looks really familiar to the one about arc length. So it's still going to start with angle over 360. And then over here we're going to have area of the sector instead of arc length. And instead of circumference, because circumference and arc length are the outside, we want area. So down here will be pi r squared. And we're just going to plug it in and cross multiply like we were doing with the previous formula. It's not a whole lot different. You just have to pay attention when you get to a question if we're talking about area or if we talk about arc length to make sure that you're just setting up the right formula on that side. So find the area of both sectors formed by this angle. So we'll do the small one first. So it looks like I've got 63 degrees over 360 degrees. That number will never change. 360 is always there. And then we've got area of the sector, which is our x. And then on the bottom, I've got pi r squared, and our r is 5. And now I'm just going to get to cross multiply. So I'm going to type in 63 times pi times 5 squared. And I will get that. So 49, 48. Essentially, I can do 0.01, that would be my 2 decimal places. And that was this diagonal. And then this diagonal is 360 times x. So now I just have to divide both sides by 360. And looks like the area of that sector is 13.74. Oh, they didn't give me anything, so I'll go units squared. And now we're going to do the other one as well. So now we're going to do the larger sector. I cannot use 63 degrees again because that angle went with this shaded part. So in order to figure out this angle, I'm just going to take 360 minus that 63. So the angle for the white part, for the unshaded part, is 297 over 360. And then up here will be the area of that sector. I won't do x again, I'll do a y. How about? So this was our x, and then out here's our y. And then down here it's still pi r squared. The radius for my circle didn't change, so that doesn't change. So I'm going to multiply these two. So 297 times pi times 5 squared. And then all we have to do is divide by 360. I'll write that work real quick. 23,326. And this would equal 360y, and then we'll divide by 360. And so the other sector is 64 point, and the 5 makes me round the 9, which rounds this, so 64.8 units squared. And then to check and see if you're right, so these are the two parts of this circle, so shaded pi wedge, unshaded pi wedge, and together they should be the entire area of the circle. So if I just did pi r squared, 5 squared, I get 78. And these two together should make about that. Keep in mind, might be a little off because I'm rounding these two. But 13.74 and 64.8 should be really close to that 78.54. And I'm pretty much right on. So that's just kind of a double check you can quick do to make sure that your math is mathin'. Make sure that your two chunked areas add up to the whole circle area. So this one says just find the area of circle V. Okay, so it's a little different, not finding the area of the sector, which they're giving me right here. So they're telling me the area of just this piece. That's why they put the number right next to this kind of pi wedge. Although they shaded it too. They really should have unshaded it. That would have been more helpful. But we've got 40 over 360. And I've already got the area of the sector. That is 35 meters squared. And then what we're trying to find is the area of the circle, which is that value down there. So the area of the circle is what's underneath the fraction. You could put pi r squared here, solve for r, and then you would just need to plug it back into the area for a circle. Sorry. So we're just going to cross multiply this. So 360 times 35, and then divide it by 40. So the area of my whole circle is 315 meters squared. Looks like it would make sense too, because if this is 35, just imagine me chunking that up into a bunch more wedges and eventually getting up to 315. So looks plausible for an answer. So very similar formula to what we were using in the previous lesson, only we're changing arc length to area and we're changing circumference to the area formula.